Yeah, Seppi, did I like refer you here to IBM? Wasn't I part of the referral? Yes, I met Seppi in Toronto actually when I was working. Yeah, was I working for IBM?
Yeah.
And then yeah, and then came back, and then I think I swear I referred you. Yeah. Anyway, this is all coming back to me now that I've like been in the like building here for a little bit. All right, so a lot of the concepts that Seppi talked about, this is going to be super annoying, have the same kind of concept in TFX, which is TensorFlow extended. So this is the sort of larger TensorFlow project. So Google, yeah, all these years since they released TensorFlow, like in 2015, has really had this sort of this much larger ecosystem called TFX. And this is, you know, data validation. This is driving schema from your data. This is using that same schema, or it's like comparing the validation, your model validation after training. It's going to run data through it, and then compare and make sure those distributions are the same. So, like basically, it's set up to like catch that skew between training and serving. So it's a very complex project. They're slowly releasing things. I think the first project outside of TensorFlow that's technically part of TFX is TensorFlow serving, and you know, which is fairly straightforward, but there's like much more. So that's what we're going to uncover. Who here has used KubeFlow? Who here has heard of KubeFlow? Just, yeah, while you're here, okay. Airflow, yeah. Where did the Airflow person? Yeah, you guys. Okay. So KubeFlow is actually a just one sort of runner or one sort of orchestrator for TFX. So again, TFX much larger, and yeah, I have images here. But okay, who am I? So yeah, Pipeline AI founded this right after IBM, right when I left here. Basically, at Databricks, which was my company before IBM, and then Netflix before that, I kept seeing the same problems over and over, trying to get models into production and trying to detect skew and basically set up advanced monitoring on models after they've gone to production. And then, of course, A/B tests and multi-arm bandits and things like that. This is actually something I tried to get the IBM Spark Tech Center to take a look at, but at the time, like IBM was still trying to figure out Spark and trying to get all that stuff under control. So also, I have an O'Reilly course called High Performance TensorFlow in Production. It's on Safari, and this is this meetup. I think we're at 11,600 people, which that's like my main metric that I keep an eye on. There's also Community Edition, which I'm going to skip for right now and get back to in a sec. But who here is okay with the command line? Don't be embarrassed. All right. Okay with Python? All right. Okay with linear algebra? Okay. Docker? How about Kubernetes? All right. And then Jupyter Notebook. Yeah, everyone. All right. That was pretty much, yeah, everybody that just kept their hand up the whole time. That was just to get the blood flowing. So why TFX? Why KubeFlow? This is kind of what I was trying to say earlier. So this is like an extended version of what Seppi showed. And there's these 6 or I would say even 8 or 10 logical systems that are required for all of this. And so TFX really helps out with this data analysis before training, right, to make sure we have good distribution. Also the actual ETL and transformation. Then helps to build the model, helps to validate the model after training. And then we're going to kind of weave in some KubeFlow stuff here, distributed training, and then rolling out the model and then serving the model. So let's see what else. Improving portability. Yeah, they have these concepts of being able to take the same pipeline and basically it's putting standards around pipeline definitions. That's really what TFX and then KubeFlow are all about. Is what we'll see later on in these examples is ways to actually put little Python decorators on your code and sort of have a DSL, right? Like domain-specific language for pipelines. So that's the main advantage of all of this. And there's a whole ton of code and a whole ton of, one would say bloat like to this framework. But at the end of the day, that's really what we're looking for is, someone to define standards. And so Google's trying to do this.
And what's the rationale behind breaking this down into 6 systems? Why not more?
Yeah, this was just one slide that I picked up, and yeah, so I actually modified it a bit. I think they only had 4 systems, but I broke up a couple because it didn't make much sense. It's just, yeah, it's sort of data it's like data validation and data pre-processing training. Okay, so this actually comes from a workshop that I did about 2 weeks ago, and I'm doing one in 2 more weeks. So some of it might seem kind of weird because we're not going to actually set up the environment, but we'll be talking about TFX. We'll be talking about how to implement pipelines with both Airflow and KubeFlow. So you can choose either Airflow or KubeFlow to use or to build TFX pipelines. So it's a little bit confusing. I'll show the image in about 2 or 3 slides. Also, hyperparameter tuning. You can't have an ML conversation without really discussing benefits of hyperparameter tuning and trying to train models in parallel to find the best like hyperparameters. And then we'll actually deploy a notebook. So Python code within a notebook. We'll do XGBoost and actually deploy it onto a cluster with just 1 line of Python code using KubeFlow. That's pretty cool. TPUs. I'll also show MLflow. Yeah, who here has heard of MLflow? It's out of Databricks. So Databricks is also trying to create standards around pipelines. And so there's this project called MLflow that's open source, and they have their own ways to put little decorators in your Python code and different core constructs. So by the way, this was a 7-hour class. Yeah, like 2 Saturdays ago. So I'm squeezing it into 40 minutes or whatever. I'll probably skip some of the Redis stuff, but you can actually make predictions with Redis. So you can load in TensorFlow or load in PyTorch straight into Redis. If you're not familiar with Redis, don't worry about it. It's like Memcache, and you can now actually load in the C modules that power PyTorch or TensorFlow and make predictions off of Redis streams, which is also a new project. TensorFlow 2.0, and then TensorFlow Privacy. Yeah, have you guys heard of Differential Privacy? This was a pretty big deal. I think it was made somewhat popular by Apple a couple of years ago at a WWDC or something around there. But TensorFlow has a first-class sub-project off of the root TensorFlow organization that's called Privacy, and I'll show some examples of that. Yeah, so all these examples are on the community edition, so you can play with it after. All right. So I'm going to go through this a little bit quick since we all kind of know Kubernetes. Let's see if there's anything worth pointing out here. Not really. Okay, so here's TFX. And this is your data coming in, so training data, and then the evaluation data. And this is kind of another view of those 6 systems from before. So loading features. So don't worry about these names for right now. We'll break them down. But basically, so the example is what TensorFlow calls the rows, the training data that's being passed in. They're called examples. Yes, I once had a 5 or 10 minute conversation with someone about that term example, and yeah, they thought that I was talking about samples, like sample code, and I was talking about the TensorFlow example. It was like 2 different conversations, so somehow we made it that one. And then statistics generator, this is going to generate summary statistics, your norm, your standard deviations on this data, which is then used elsewhere. So put that on your stack here for a sec. This is actually validating and then generating schema from, so gen stands for generator. It's just the goofy names TFX chose. Schema generator also comes out of here. We then transform, pass it to the trainer, trains the model, and then we start to evaluate the model. And then last step is we push it. Some classic places to push it would be TensorFlow serving, TensorFlow Lite, it's kind of the smaller mobile devices, the JavaScript, and then there's something called TensorFlow Hub, where you can register pre-built models. And actually, I just saw, I think it was today or yesterday, where they released PyTorch Hub. So there's actually a similar thing out of Facebook. Oh, and then two other things to point out. So this is TFX. You can use Airflow or you can use KubeFlow to actually make this happen. And I'll show examples of both. And then down here, there's this metadata store. And if you're familiar with tools like Pachyderm or ways to store the intermediate data and then have complete traceability and then like reproducibility. So this is kind of a dinky project right now. And by dinky, I mean not very well understood or like documented, but we'll actually run a full notebook that'll kind of like tear this thing open and see what's inside. But this, I think, that metadata store will likely become much more broad and like useful as like TFX starts to come to actually get pulled out of Google. All right, so here's the Airflow version. If you're familiar with Airflow, so this is a DAG, and it kind of maps to what we just saw, down to the pusher. And so each of these is actually Python snippets of code. So that's very important. That's actually one benefit of Airflow, is that each of these steps is just a small snippet of Python. As opposed to KubeFlow, which kind of looks pretty. Each of these is actually a Docker image, which is super annoying. And this is where you can tell this has been designed by systems people or by engineers and not necessarily. So it's a nice view, a nice data science friendly view, which we'll show here in a bit as well. We'll show the experiments, we'll actually compare runs and see those models rather getting deployed. Okay, and then hyperparameter tuning. This is a sub-project called Kati. Yeah, do you know what Kati means? Yeah, no, and so here you could do the classic Bayesian optimization, grid search, random search. You could use hyperband. You can introduce your own. And yeah, compare runs. Yeah, has anyone used Istio? This is for traffic routing. This is actually not a primary portion of this talk, but it's the ability to deploy 2 different versions and then route and send 80% of traffic to this, or send like anyone in San Francisco to the E2, because maybe we're better equipped to handle that like new version and maybe some bugs, some crashes. Yeah, so Istio handles this. It's more on the prediction side. So once the 2 versions have been built, or the second version has been built, we would deploy it and then set up some rules. And then, yeah, one cool thing is that we can actually shadow traffic too. So we can have all the traffic maybe that's 100% goes to A, and then B just gets like 10%. Or, yeah, no, sorry. In the shadowing case, it's a best effort. So both models get that same data coming in, but it's only model A that's actually being sent back. That response is being sent back to the caller. So B is still being logged, and we can build dashboards to compare A and B, but it's done behind the scenes, and it doesn't affect production. All right, some TFX internals. This is a little bit lower level. This is more for people that want to build new gens and new transformers. There's this little driver piece code that you extend to the next computer in some way to get data from that meta store and then push that result back into the next store. So that's the base interface for all the other components that we find. Yeah, this metadata store, it's storing all that lineage info, it's tracking inputs and outputs, it's tracking versions, and all the good stuff. So that's why I'm saying there's a whole lot of potential for this meta store that really hasn't come out yet. And it's kind of interesting to see that like Pachyderm guys like really want to stay on top of this because this could potentially, right, like conflict with Pachyderm's business model. Yeah, we're not quite there yet, right? Like Pachyderm does this much, much better, but something to keep an eye on. All right, and then these are the, so these libraries actually cross-cut. So if we go back here, let's see. So we just talked about the internals. Now we're going to talk about the libraries. Then we're actually going to talk about those components. So that's how you build a component. What we're going to talk about now is some sort of utility functions that are very much geared towards data validation, model validation, things like that. And then the other components that actually implement those libraries, or like use those libraries. So these are the 4 big libraries: TensorFlow data validation, TFT, TensorFlow transform, TFMA, TensorFlow model analysis, and then TFMD for the metadata. So TFDV, this is data validation. So this is actually a Jupyter notebook. This is a cell within Jupyter. This is part of those examples that are included, by the way, so you can reproduce this. And we're able to actually look at the data coming in and identify if there's certain features that are all zeros. So this is highlighted. You can sort anything that's not uniform. This is showing you the distributions here. And so this will actually highlight some of these values, or these features that are not behaving very well. Yeah, so speaking with Sebi before, this is kind of the super like bare bones open source version of the Watson stuff. So you can identify missing features, important features, redundant features that are unusually large scale relative to the other features, which is really bad. This is why you want to normalize, so that you don't start swaying the model one way or the other. And this will also help us detect data drift later on. So the next one is the transform. And so think of this like the normalizer. So you would learn about your data from the step before, or from that previous library. And now we're actually going to transform, and we're going to normalize. We'll create vocabularies. We can bucketize. The output of this is a TensorFlow subgraph, which can then be reused. Right? So this is feature engineering, which has to be reused during the actual inputs. So that's why this is really nice. This is huge. So we can reuse that across both training and serving. And yeah, here's an example. So there's one, this is Python code, and there's one method that you can implement. And I think that's the normalizer. Okay, TFMA. So this is the model analysis. And so down to code level, inside my Jupyter notebook, I'm actually either pip installing or I've already pip installed these libraries. Okay, and I can start doing this analysis directly within my notebook. And this is where you can start to send in slices, right, like horizontal slices, so subsets of data, and start to look at these distributions and see what's going on. Oh, yeah, sorry, this is model analysis. So we're sending in rows and pretending as though that's the only data that we have and showing what the model's predicting. So this is where you can identify certain slices and certain biases, things like that. Let's see. Okay, and then metadata. I think I talked about all this already. Yeah, we could like record, retrieve, experiment metadata, and lineage. All right, so now we're going to talk about the components. So this should go pretty quick because we understand all the like fundamentals. So the example gen, this is what is actually like reading in CSVs and TF records. So TF record is like Parquet, but it's specific to TensorFlow. But it's a file format that's optimized for machine learning workloads. You really want to be using TF example, which is why this is called example gen. This is that conversation that I was having with someone about the wrong concept. Yeah, TFX pipelines don't actually require this, but you could do quite a bit more if you use TF example, because all these libraries use TF example. And this actually isn't, yeah, well, that's not quite true, but. All right, statistics gen. So this is looking at all the data. So this is cases where you want to actually look at the entire distribution and then learn about all the data all at once, right? Like versus just sort of mini batches. Schema gen then creates the schema.protobuf. So that's like a JSON file, but super hard to read and binary, which is the schema, which is then used later on. This is a best effort schema similar to Spark. You kind of want to analyze and make sure that the schema that's been inferred is correct. And then the example validator is using that schema. It's validating. It'll highlight anything that's not what you're expecting. And then, yeah, that's an example of the schema. So transform, yeah, like I said, this actually generates a TensorFlow graph. And then trainer. So this is the actual model trainer. So all that was just the pre-processing and the validation. Okay. TensorFlow 2.0 is not really supported. I think it's getting there with the next release of TFX. And then the evaluator. So this is for the like TFMA. So this is the step where we can start with. Now that's actually KubeFlow showing this. So one cool thing about KubeFlow is you can build these custom renders, which we'll see in a minute. That you can actually click on one of those nodes in the pipeline, pop up the artifact that was generated, and then if there's a proper validator, right, like TensorBoard actually pops up. There's this link to say open TensorBoard, which we'll see in a sec, but that's a valid way to look at that model that was trained. Okay. So this validator, the kind of base version is you can set up rules and say, if my accuracy beats the previous accuracy, right, like you were talking about, in some cases I do want to push it. In some cases I might not. Maybe I want to look at more than just the previous. Maybe I want to look at the last 10. This validator actually gets kind of, or could get kind of fancy where, is that the next slide? No. You can build a Slack validator that sends a Slack message, right, like to the team, with the link to the experiment and says, click here. You can evaluate it, right, like human evaluation, and then just respond LGTM or yes or approve or something. Yes, I can't remember which one, but that will then continue the pipeline. So it's sort of human in the loop, right? That's allowing this human to actually verify this model. So yeah, I'll talk about that one next. Model pusher. So as simple as it sounds, but it's also writing version data to the metastore. And here's some more on that cool sort of human in the loop step. So this is actually a separate step. So there's the validator, and then you would add in this new Slack component that can then send it out, and then we'll handle that response from the human. And if you've ever done any Slack like integration, it's super cool. You can use like fun emojis and everything. And so this exists. This is actually a real component. You tell it what directory your model was exported to. You give it the Slack channel. You have to configure it with your Slack API and your Slack token. And then it'll wait for the response and then continue on.
Question, there was something missing there, right? You're saying that it's possible to assess whether the model that was just trained is better than the one in production. So there on the left, it looks like you have the training data set, you have your validation/evaluation data set. I assume you use that for cross-validation. And to decide that the model should be pushed out of production, do you have a held-out data set somewhere on the side?
Yeah, so, right. I kind of skipped over that part, but it's a pretty big start. So, or step. There's this eval save model. And that's generated at the same time that the save model is generated. So save model is just the name or the format of like TensorFlow's exported model. And that actually contains those slices. So really what it requires is the human has to go in and run this like validation sort of manually, right? Like doing that slicing. Let me show you. Right, like doing this part. So that link that's sent from the Slack component then gives you the ability to look at the slices and say whether or not this is good. And then, yeah, also other like metrics like the accuracy. So this is a trained model. This is the library that's used by that model validator step.
So usually in TensorFlow, the validation data set is used to cross-validate.
Yeah, to cross-validate, yeah.
Right. And there's another data set which would be like a test held-out data set.
Yeah.
Never actually used anywhere in this pipeline.
Right. There's no hyperparameter tuning happening right here. So there's only two. There's just the yes, I always forget which one it is, the test or the validation, but there's no cross-validation happening here.
No cross.
Yeah, yeah.
But then it sounds like there's not enough information to decide whether or not the model that just went through this pipeline is better.
You can build, yeah, so you can build, yeah, yes, I know what you're asking. You can build your own custom code here to actually do that. Yes, I know what you're asking, yeah. It's not in any of the samples that I've seen. We'll talk about the hyperparameter tuning, but it's a separate. So what you'll see is TFX right now in its current state, and actually KubeFlow, is a bunch of sub-projects that have been kind of loosely combined, and they just happen to all point to the same directories. So, but they haven't yet been like integrated. KubeFlow is basically a completely separate project from TFX. TFX has been there forever, and KubeFlow's like, hey, yeah, this is kind of an updated UI, but yeah, uses some of the TFX concepts. All right, so in the bottom right is actually the distributed. It's kind of out of place here, but it's a way to do distributed training with KubeFlow and TensorFlow. Skip the bottom right for a sec. Yeah, like we'll talk about that here. Yeah, so Airflow, I think pretty much, yeah, every shop I go into, people use Airflow. It's just what's there. What's interesting is that TFX seems to prefer like Airflow. And, you know, again, you can kind of tell maybe like Google's using it internally or has a similar version, or they just like the idea of having Python, right, and not separate Docker images for everything. So the short of it is that the clearest path to using TFX today is to just use Airflow and not get into this Docker image versioning and, you know, chaining together outputs of like Docker images. You know, pretty good community support for Airflow. This came out of like Airbnb. Seems like forever ago now. The UI hasn't changed probably in 5 years, 7 years, something. And then KubeFlow is actually based on this project out of Intuit called Argo. And it's more of a visualization and sort of CI/CD type thing. And KubeFlow picked it up because it was Kubernetes friendly. And then realized that they could actually like reuse the UI components from the CI/CD portion to that same file format and storing of those DAG definitions, and then visualizing those DAG definitions for the pipelines. So there's the sub-project off of KubeFlow called TF job, and this is how you do distributed training. It's a bit clunky. You have to define this wacky YAML and define various things, but with KubeFlow, we could actually do it with just one click. So I'll show that here in a sec. And then there's this slick project that kind of came out of nowhere. It's called Fairing, and this is how we can and will take that XGBoost Python code in the notebook and actually deploy that onto the cluster. It's pretty cool. This is actually one of the closest projects I've seen. So there's this sub-project called Papermill, right? And Papermill is actually used by them. So Papermill was created, I think, out of Interacts, made pretty popular by Netflix. Netflix uses it pretty heavily. You could schedule notebooks as jobs. And so, really, at the end of the day, if you've ever used Databricks, that's really what Databricks is good at, is taking a notebook, scheduling a job, and then managing, the Amazon Azure clusters behind the scenes. Okay. Also, Fairing is smart enough to figure out what are the dependencies of the Python code that's being run. And I still don't know how it does it. I keep meaning to look at it. It's not like we have a JVM that we can inspect. This is like crazy Python stuff. But they can actually create the Docker image from this notebook and include the requirements.txt. It's magic. All right, hyperparameter tuning. Pretty straightforward. They use some goofy terms. There's trials, there's studies. The suggestion is the actual algorithm, which doesn't quite make sense to me. And jobs run and actually, and so the whole point, of course, is to try out different hyperparameters and figure out which ones give you the highest either accuracy or validation accuracy, whatever metrics that you're trying to optimize. Oop, I'll plug in. Oh shit, this is the new. Do you have the old Mac? Yeah, my battery's gonna die. Yeah, I have the old Mac. Does anyone have the charger? Yeah, this will be a quick talk.
This guy?
Yeah. Yeah, I have the older. Oh,
yeah.
Power Strip.
Power Strip. Is that what you were looking for?
I found a weird one down here.
Yeah, that's what I thought about that one.
Okay. All right, so deploying this notebook as a job seems like it should be pretty easy, but of course you have to create the Docker image. You have to deploy the notebook, that image onto the cluster. And so I'll show that in the example here in a bit. Actually, I'll show it right now. Okay, and there is a full workshop coming up in a couple weeks. I think it's the 13th after the holiday. If you want to sign up, just go to Pipeline AI. There should be a link. Let me show you the notebooks. All right, so one thing I like to do with the workshop is to actually show the Kubernetes cluster, so each person gets their own instance, and then we can actually inspect and look at the kube cluster. Some people are curious. If you're not curious, then just skip it. This is the environment that we're working in. And yeah, some of you, like Jupyter geeks, know that you could do %% HTML. I love that. That's the coolest thing. All right, so that's just kind of showing the TensorFlow environment. I think the next one is the Kube cluster. So this is KubeFlow and TFX and Airflow. So this is everything that's powering. I'll show you guys the. So yeah, all of this, yeah, each of these. So there's Airflow pipelines, KubeFlow pipelines, TensorFlow jobs. These are those TF job distributed things. Hyperprimary tuning and ML flow. So I'll show quick examples of each of these. But this is the entire shebang. Busier, just in case you catch this and are wondering what it is a paper by Google, was implemented as part of KubeFlow. This is actually part of that Kati project. We got, of course, Jupyter, got a bunch of UIs. That part of the UI that's actually showing the KubeFlow pipeline you see. Study job, this is part of the hyperprimary tuning Kati. These are actual pipelines that are still currently running and you feel completed. All right, so here's an example of the data validation. So this is the Chicago taxi data set, trying to predict tips from various inputs. So there's our input features. And I'm just going to skip down and kind of show. So here's what was in that slide. And you can, inside the notebook, actually start to click and see which features are the most important. We can look at non-uniformity. So we see 27% of the trip miles was 0, something to keep an eye on. Tips is 0, that's probably not good. Cheap ass Chicago people, of which I'm one of them. Yeah, I just forget to give a tip sometimes, I think. All right, and then, so this is actually visualizing the stats of all of the examples of that training data set. Here we're inferring the schema. So this is using all those TF libraries, TFDV. So you'd want to scan this, look at what's optional, what's required, and update it as needed. And I'm going to do the annoying where I skip through too much. But yeah, so you can check these out. This is where you can start to analyze drift, start to analyze skew. At this point, I actually want to use the Watson stuff instead of this. I've been looking at these crappy screens for so long, but it would be nice to have actual structure and nice UI. I'll skip the transform stuff. It's pretty straightforward, just doing ETL. And then here's the big one. So TensorFlow model analysis. This is where we're going to run those different slices of data. Bear with me for a sec. Oh, there we go. This one takes a little bit to run, so let me rerun it here. And then the Airflow pipeline. So I'll show a quick example of that. So here I can click and I can see which steps actually failed, which one succeeded. Yeah, this one looks good. It actually made it all the way out to pushing the model. So we can look at our Kube cluster and actually see our model deployed as a TensorFlow serving pod or that Docker container. So, and then here's KubeFlow. So the one cool thing about KubeFlow, like I said, is you can actually click on, I can go to an experiment. I ran the taxi experiment. I have 2 runs. I could see the two like metrics I was looking for. So accuracy score and then ROC, AUC. It's pretty simple, but at the end of the day, yeah, this is how I explained it for that workshop. Like last week, 2 weeks ago, was at the end of the day, this is just defining a way to create my output from my training job and then be able to visualize it. So it's not just these two columns, but I can actually go into each run, click here, see the inputs, outputs. This one's not too interesting. Although, here it's like pointing out the anomaly. It's just saying it's containing missing values. Let's see. What we want to keep an eye on is for these artifacts. Okay, so this step is the actual trainer. It's running, and then so I could actually kick off TensorBoard, which then points to that directory where that model was output. So again, just defining standards. At the end of the day, we're just saying, right, like where did the model end up? Where's the input data? And then being able to visualize it. So yeah, familiar TensorBoard stuff. And then after the model's been trained, we could actually like analyze it. And this is the exact same thing that we saw in our notebook. It should be soon. So this is after the model's been trained. We could look at the different slices. And then, let's see. Here we could look at the details of our ROC curve. Fusion matrix. Pop this out. We could do batch predictions. And let's see. Go back to here, see if this isn't working with me. So the stuff that runs inside of the notebook is actually, it's like implemented as a notebook extension, and you have to like refresh the browser and then rerun it. It's a goofy thing, but anyway. Yeah. Yeah. Yeah, you can specify either S3, Google Cloud, storage. Here, we're just using a shared file system, so it's just NFS. Yeah, so for the hyperparameter tuning, yeah, let me show. For that one, you could say run 3 in parallel, run 6 in parallel. Yeah. What I thought you were getting at is, what if you run out of capacity? In which case, that's a Kubernetes thing. You have to tell it to auto scale out and scale back in. So, yeah. If you're doing hyperparameter tuning, you're doing things in parallel. It's going to be best effort once so once they finish, it'll then schedule more. Yeah. You can, yeah. There's always, yes, the raw like YAML that you use to like define these things, you can actually put those in. You can put in how much CPU and then how much memory. Certain parts of KubeFlow let you do it, certain parts don't. It's, again, because it's this kind of loose collection of separate projects. They're all at kind of different, yeah. Yeah, that's a good question. 0.5. Yeah, 6 is being cut this week. And still has some like pain points to it. So here's TensorFlow. So this is the distributed job. This is where, when I defined it, which is up here, when I ran this, so here I could say 3 replicas. I have to give it, again, a Docker image. I give it this group name, which translates into this. That thing right there. And then I could actually drill in and look at the logs on each worker if something failed. This is one of those UIs that needs some serious love. Here's the parameter optimization. So let me show you the YAML. So again, there are ways to kind of, right, like the tooling hasn't caught up yet. So right now we have to kind of manually define this YAML. Optimization goal, 0.99. I'm actually going to render all this in the UI here in a sec, but this is what it looks like. This is my feasible range. My learning rate, feasible range for the number of layers. Optimizer is a categorical hyperparameter of, what did it give? SGD, Atom, FTRL. Let's see, request number. And then this is, so yeah, so this is where you can start getting fancy with the resources. Like this is physically like Kubernetes. This is actually an NXF model. So here's the results of the random search across that space. And these are, so the goal is to maximize our validation accuracy, stop early if you get to 0.99. This is our feasible space. As defined in that YAML, there's SGD, Atom, FTRL. And then someone told me the other day that this visualization was actually created at IBM. Is that true? Do you guys know the name of it? Yeah. Oh, God. Okay. Yeah, we'll give IBM the credit today. So you kind of, I guess, like the way to read this is what you're optimizing for. Each of these lines connects. So these are at different scales, obviously. But these are the 3 hyperparameters, and then they led to and the other thing you could do is just come down here and sort. And you can see that we never quite reached 0.99, but 0.981, and these were the different combinations for the validation accuracy. And then let me show. Oh, so here's that fairing stuff in action. So this is deploying the XGBoost that's in a notebook cell or in a notebook, and so this is defining the model. This can actually download the data and all that. Training the model, and then this is the code that can deploy. So this, like beneath the covers, if I run it, let's kind of skip that. That's just setting up the Docker registry. This is actually going to create a Docker image and then deploy it to the cluster, and we'll see it running. So building image. And then we can actually, it's tailing the logs of that pod as well too, right here in the notebook, so you can see. So that's kind of slick. The last one, oh, and then, so this is cool. So I showed you guys the KubeFlow taxi one. That was kind of the advanced version. This is just a simple KubeFlow pipeline that I'm going to create right here. So I'm defining this add function, and then I'm creating an operation. And so this is where you see the word container, because it's including involved by system people. I'm actually creating, I'm So this is the KubeFlow pipeline Python library that we took installed. And there's something called component that can convert that function that's defined up here into a Docker image operation. It's actually not going to create a Docker image. This is the lightweight way to do this and not actually create the Docker images. And then here's another function, divide, where we're going to divide to. We can nest other functions here. And this is, if you remember before, I showed you the two metrics, the accuracy and the ROC curves. This is where this is a standard way that KubeFlow gives us to define the metrics and the objective metrics. So it's not the same. It's a quotient, it's a simple model quotient. So basically, this code is going to add two numbers and then divide by another number. So this just tests that works. Let's see. And now we're creating this operation. So we're converting functions that are in Python inside this notebook into operations that end up as part of a DAG, a pipeline DAG. So here's what I was saying, is the decorators using this KubeFlow pipeline DSL. And those are the numbers we're going to be adding and dividing. Here's our add operation. Here's our divide operation. So you have to define these pipelines in terms of the operation, not in terms of the Python function. So then we're creating, we're just kind of following the goofy KubeFlow pipeline standards here. You have to tar up this bundle, you have to compile that pipeline. And then at the end of the compilation phase, it's tarring up a single file that's pipeline.yaml, and it's this big blob of YAML craziness that literally. Let me see what I think I could just output it here. So if I can't with the tar. The file. Anyway, it's, oh, yeah, here it is. So all that compile phase did was create this YAML file. Double tap this. If you notice, it's created a file that's referencing Argo as the type, workflow, giving you parameters. So this was the standard that they chose to define pipelines, comes from that Argo project, which is doing that actual visualization. And then check this out. This is the craziest thing you'll see here. So that add function ends up as a -c. All of that code ends up as a big blob inside of this file, which then gets executed. That's, by the way, at some point beneath the covers within the Watson stuff, there's something going on that's just as crazy, I'm sure. Except here we actually have to pay attention to it. So at the end of this gives us a pipeline, a KubeFlow pipeline. Experiments. Added it to an experiment. So here's the two metrics that we chose to output, the quotient and the metrics, but showing you how that works. We can click, we can see First we did an add, then we did a divide, and then we did another add for some reason, just to be fancy. You can see simple. So here, like, we can click on each of the stages and see the inputs and the outputs. The logs here is literally, if this was a Docker image or a pod, it would be showing the pod logs. There's not really any logs coming out of these, but because this was kind of that like lightweight version of the pipeline. Okay, this is the very last thing I'm going to show, which is the MLflow stuff. So this is the Databricks library. The main point for this, again, is to create standards as a way to track experiments and then visualize and compare runs of these pipelines. So they have their own library, which we pip installed up here, MLflow. And the two things, I'll skip through a lot of this. There's an experiment name, which is what actually shows up in the UI, similar to KubeFlow. The other thing is we're starting a run, so we're using Python Context Manager to say with start run. So implicitly, there's a run object being created that the next calls to MLflow will be attached to. And with, like, yes, any experiment is going to have parameters. And it's going to have the output methods. And we're actually going to log them all. Now, this is a pretty powerful step. This is going to also grab the code from the notebook, figure out what are the actual conda requirements, yes, in this case, and generate all this for us. So if I skip over to the MLflow UI. So here's, I did 2 runs when I was sitting up here earlier. I did 3. I did 4. So I can compare all of these. So, again, these are the parameters that we used that were logged. Those are the metrics that were logged from each run. Now we're going to compare. And we could start to plot these and do all kinds of fancy stuff. We can drill in, compare the root mean squared error across these runs. These have unique run IDs, kind of garbly group hashes. So what's surprising is I present this last because it's kind of the least exciting and the least buzzworthy. But when I show this to clients, this is the simplest way to actually get the metrics tracking versus Docker images and all funky pip installs of creating operations out of functions. This is just simply the code here. I'm tracking the parameters, I'm tracking the metrics. Oh, and then I didn't show the, if I drill into one of these runs, I can go down here, open it up. It has pickled the model for us, right? That one function. This one function, so it supports scikit, it supports R, supports TensorFlow, Keras. You would say, yeah, MLflow.keras.log model. You would save it as the but what's really cool is it actually shows us or figures out what those conda requirements and then dynamically creates a conda.yaml, which is conda's version of the requirements txt. It also generates this like MLflow specific ML model file. You don't really have to worry about that, but it'll track the Python version that you're currently using. Tells you what the serialization format is. You can modify these. So there's a way to have an ML project file where you could actually explicitly say the serialization format, all that. But what I like about this is I didn't have to think about all that. I just called that log model and it created that. All right.
Question about this is the full pipeline, right? You mentioned that technically you can write the implementation that uses package
So yes, MLflow is very Spark friendly. KubeFlow is not very Spark friendly. Yes, MLflow comes from Databricks, which is like the Spark people. KubeFlow, I think I've seen a Spark example. I think I might have tried to get it to work. It didn't work. But with MLflow, you could actually, this has first-class support for Spark jobs.
What about
Yeah. No. You would have to do it yourself. So I actually don't like Beam is an implementation of how they're able to stream through all the data. And so I understand why it's there. It's this other layer that throws a bunch of warnings and errors that I don't understand. It didn't even support Python 3.6 until like 2 weeks ago or something. So, but the short answer is, if you're using Spark and using Spark streaming, you would want to use MLflow. And it's kind of nice for just straight up Scikit and TensorFlow as well. So that's kind of the anticlimactic ending, is after all of the work we did on the KubeFlow and the TFX, I actually kind of like MLflow better. Yeah. Yeah, that paper mill. Yeah. Yeah, so the cool thing, yeah, I mean, it's not even, it like wasn't even created by Netflix, but it's a simple way to cron schedule these things, right? And the cool thing is that it takes as input, you have to annotate your like notebook cells with these, these like parameters or labels, and that has to match label or the parameters coming in on your cron like invocation. So yeah, that part's kind of weird, but yeah, there's really no other way to do it, I guess. The output is a notebook file with all the cells rendered, right, and all the output. So yes, I like that part where you could actually just pull that up, that output, see all the visualizations that have been generated. Yeah, it's more popular than I thought. At the JupyterCon conference that I was speaking with Rosie about, yeah, Papermill was all over. I mean, it's a Jupyter conference, but yeah, more people use it than I thought. Oh, yeah, I think it was just the simplest is the eager execution stuff. So I think that was really the only example that I had. Yeah, was eager execution for that one. But yeah, I have more. Yeah, I have like whole talks on the 2.0 stuff that I could send. But yes, privacy stuff. Yeah. So differential privacy, and this is using the library from TensorFlow. So with privacy, there's a natural balance between private training and then accurate training. You kind of have, there's this trade-off. And there's this third trade-off of like latency during prediction, right? So really, you're balancing three things. But for this discussion, you can tell TensorFlow what your privacy budget is. That's the term. And then ask TensorFlow to find so this is all based on something called differential privacy. And differential privacy at its kind of highest level, most basic form, is introducing noise, right, like during the training process, so that you like lessen the ability to figure out if you pass in an input, if that's the actual prediction. That's how do I say it? It's a way to sort of mask the real data, but no, that's a bad term too, because so what you would typically do for like private training is you would like mask certain fields, right? And just get rid of those columns. I'm not going to train with these. But like, what if you actually need those columns? This is part of the model. So what you can do is, as that data is flowing through the training process, you can introduce noise. So think of like flipping a coin. So 50% of the time, the person's telling you the truth, and 50, and like, yeah, they're not telling you the truth. If you're asking someone about, like, who did you vote for, Hillary or Trump, you would flip a coin. If it's true, or if it's heads, that person has to tell you the truth. If it's tails, then they can lie to you. That's kind of the highest level. And so what you do then is, because it's somewhat deterministic about the noise that you're introducing during training, when you go to predict, you can subtract that. But it sort of lessens the ability to pass in someone's like unique information and see who they actually voted for, because it might be the truth or it might not be. And so what you do is you give TensorFlow this privacy budget. And if you want 100% privacy, you'll have a really shitty model, but you'll have 100% guarantee that they can't be sure that this was who they voted for. And so you have to figure out this differential privacy has these hyperparameters. And really, at the end of the day, it's wrapping the existing optimizer. So there's the differential privacy optimizer that wraps the existing TensorFlow stochastic gradient descent optimizer. And so there's the step before where there's hyperparameters that go in, and they're specific to the differential privacy optimizer. So you tell TensorFlow, I want 5% budget. And then it'll figure out, based on your model, what is the actual hyperparameters. It's a very deep topic. There's actually not too much out there on this, which is interesting. When I first heard about it was that Apple announcement. I didn't really think too much about it. That was a couple of years ago. And then when I saw TensorFlow release this privacy library, then started looking into it. Found some resources online, but actually, Facebook just announced, I think today, I think it's a Udacity course. And Facebook's all about fairness and all about privacy now. Right, like this kind of privacy, not don't show my pictures to my mom or whatever privacy. And it's using differential privacy, and there's a whole course on it, which is really cool. So that was the privacy stuff. Oh, and then at the bottom, so this is telling us that we had really crappy accuracy because up above, I gave it some pretty extreme privacy budget. So try to maximize privacy, and then I got really crappy. So this is where you would hyperparameter to and find. But the problem is, if you talk to the business people or the legal team, yeah, they want 100%, right? Because otherwise. Oh, and I guess the fundamental problem also is that if you remember that Netflix challenge from a bunch of years ago, where Netflix released a masked PII friendly data set, but people were able to combine that data set with the IMDb data set and then start to uniquely identify people. And so differential privacy and things like this help with that. Okay. Any other cues? Yeah. Yeah, that actually popped into my head. Right. Yeah. I think I'm probably combining two different things, but. Yeah. If you're combining mask data, if you're doing, okay.
But the algorithm can still figure it out. Is the algorithm doing some version of combining information and saying I can work down your lies images? So in this case,
but when you pass it through the model, you're not 100% sure that that's the real prediction, right?
Yeah. You gotta be reasonably sure,
Yeah.
otherwise,
Otherwise, you have a shitty model. Yeah.
and if you're reasonably sure anyways, reasonably unprofitable.
Yeah, so I'll leave that for the reader. This guy. Yeah.
So that one particular feature will impact on the model. So we put that in the model that feature.
Yeah. So, there's like one more piece to that too. That yeah. Anyway. Yeah, does the air conditioning turn off in this building after a certain time? Or is it just me? I think I remember that last time. Yeah, it does? Okay.
Another question. When you should deploy on KubeFlow and when you should
Yeah.
deploy to the Spark or the other cluster that's I need guidance.
Yeah. Oh, well, KubeFlow versus Spark is the question?
Yes. Yeah. Basically, you have two options. I do not know.
Yeah, do you mean Airflow and KubeFlow? Or
I mean KubeFlow versus Spark or one of them.
yeah, you can. So I don't know much about KubeFlow plus Spark, but is like your question about resource?
Yeah, you have the model. You
Yeah.
have option to deploy. You can go install it on the server. You probably wouldn't do. You can try to containerize.
Yeah.
It's also not very workable approach from that scale.
Yeah.
Or you can go to KubeFlow, or you can go to the Spark. Everybody opted to the Spark just because it's pretty computational intensity
Mhm.
with the KubeFlow and the scalability of the
Yeah.
cubes and parallels. Any guidance?
What kind of pipeline in KubeFlow? Like a hyperparameter optimization type of pipeline?
Any
and then-
machine learning, any generic machine learning.
Yeah, because a question came up a couple weeks ago at the workshop of how
Okay, let me give you an idea of what I'm thinking about. Okay, you have relatively small model, let's say 20 gigabytes of machine learning, but you chunk half of terabyte of the data. So that means that you have to stream through the half of the terabyte of data through the queue.
Oh, I see what you're saying. Yeah,
Versus logistic where in Spark, it's already there.
it's already
almost there.
partitioned. Yeah.
So let's have it.
Yeah. So Beam. So the reason that they use Beam is you can distribute and stream that way. So there would be multiple inputs, and the idea. Yeah. So they always, of course, push Google Cloud Storage, but with S3, you're pulling in parallel, right?
Yeah.
So. In like KubeFlow, I wouldn't use it for that use case right now, just because it is wonky and a little bit. So I would stick with Spark for now. But and it's also because I don't really understand fully the Beam side of things. But yeah, that's exactly what they're using Beam for, is to be able to stream through. And then there's distributed Beam, which does it in parallel. I would stick with Spark. Yeah. All right. Was it worth your time? Sort of. Yeah. Yeah. Oh, it was. Okay. Phew. Thanks. It was like no response there. Thanks, IBM. I feel like I've seen it before, right? Can you come to this?
Maybe like a rise or something.
Oh yeah.